for C++ chapter 1 revision. As I mentioned in previous audio, we need a programming language in order to solve a problem. Also to get quality software product. To get quality software product or program, we need to pass some stages. That stages are the first one is collection and the requirement analysis. The second one is design. After design is coding. The fourth one is testing. After we code it, we have to test. The fifth one is maintenance. So let us see this stage one by one. Okay. The first one is requirement analysis. This means simply to achieve the desired result. We have to analyze the requirements, which means what we need. Customers typically know what they want only. Customers know only what they want, but they don't know what software should do. Okay, so to achieve the desired result, we have to analyze the requirements. Okay, we have to analyze the requirement, or in another way, requirement analysis. When we say feasibility study often carried out understanding the problem at hand and analysis of data and the procedures needed to achieve the desired result. Customers typically know what they want, but not what software should do. Customers only know what they want, but they don't know what software should do. Okay, to understand what are the requirements of a system, requirement engineer include the following activities: feasibility study, requirement election, requirement analysis, requirement specification, and requirement validation. The second stage is design. After we analyze our requirement, we are going to design. Okay, when we say design, once a requirement of the program are defined, the next stage is what? To work on design of a system. So under design, when we say design is a part of solution phase. Okay, represent the software system function in form of that can be transformed into one or more executable programs. Some types of designs are architectural design. Architectural design identifies subsystem. Interface design. When we say interface design, this describes subsystem interface. Other is data structure design. This design data structure to hold problem data. And another one is algorithm design. Under algorithm design algorithms for problem functions. Design algorithms for problem functions. The third stage is coding. After we analyze our requirement and after design, we are going to coding. Okay, or implementation. When we say coding, another name of coding is also what? Implementation. Is the stage where each statement for the design is translated into targeted programming language. Under coding stage, okay, or implementation stage, this stage is what? Where each statement for design is translated into targeted programming language. The selection of the targeted language may depend on several factors. An important task of coding, other than actual algorithm, is documenting the internal design of a software for purpose of future maintenance and enhancement. Okay. Now we come to the fourth stage, which means the first stage. On the first stage, we have collection and the requirement analysis. After we finish this, we are going to the second stage, which means design. After we design, we are going to the third stage. We are going to code it. Okay, which means the coding. Now after we finish our coding, we are coming to what? The fourth stage, testing. Under testing, once a program is implemented, the next step is to test it. Okay, program testing involves two steps, namely debugging and testing. When we say testing, making sure that the program does what is intended for. Testing means making sure that program does what is intended for. Okay, and the debugging, it is about error. When we say debugging, error in program are called what? Bug. And the process of locating and removing error is called what? Debugging. Okay, you have to know this. Error in program are called what? Bug. And the process of locating and removing error is called what? Debugging. Okay. The last one is maintenance. Under maintenance is, when we say maintenance, it is the process of changing a software. It is the process of changing a delivered. It is the process of changing a delivered. It is the process of changing a delivered. Okay. It is the process of changing a software after it has been delivered. There are many reasons why programmers must be continuously modify and maintain the software. One is, the first reason is what? New user needs. Second, previously undiscovered bugs maybe, or also changes in hardware platform. It may be cause for maintenance, efficiency improvements, and documenting as well as committing. And there are a lot of things that may be a reason for maintenance. Okay. When we say algorithm is a procedure or formula. Algorithm is a procedure or formula for solving a problem. Okay, it's what? A finite set of ambiguous steps or instruction for solving what? Problem. The term algorithm comes from Al-Khwarizmi, 9th century Persian mathematician. Okay, it's a Persian mathematician who was lived in 9th century. Algorithm is a procedure or formula for solving a problem. Okay, therefore, to solve a certain problem, we need an algorithm. Suppose you are required to put following words in alphabetical order. For example, apple, zebra, abacus, and a bug. If I say put apple, zebra, and abacus and a bug in alphabetical order, the first thing you do is what? Look for a word that starts with A. Because I say that put in alphabetical order. Look for the word that starts with A. Then, if you find a word beginning with A, put that word at what? The beginning of the list. You say this in your mind, okay? Look for another word beginning with what? A. If there is another word beginning with A, then we will compare it with what? With the second letter, which means another jump from A and we come to another second letter, and we compare them with that. Okay, if the second letter are different, put the two words in alphabetical order by their second letter. If the second letter are the same, proceed to the third letter again, and so on. Repeat this whole process for B, each other letter in alphabetical order, until all words have been moved to the appropriate place. So this is what we call what? Algorithm. So what is an algorithm? Algorithm is a finite set of ambiguous steps or instructions for solving problem. When we say algorithm, it's what? A finite set of ambiguous steps or instructions for solving what? Problem. The term algorithm comes from Al-Khwarizmi, 9th century Persian mathematician, okay, who was lived in 9th century. Algorithm is a procedure or formula for solving a problem. Okay, therefore, to solve a certain problem, we need an algorithm. Therefore, algorithm should be simple, should be correct, and should be efficient, and should be what? Finite. Okay, we have three categories of algorithmic operations or control structures. The first one is sequential operations. The second one is conditional or question asking operation. The third one is iterative operations or loops. Let us see them one by one. When we say sequential operations, instructions are executed in order. Okay, sequential is what? Instructions are executed in what? In order. When we say conditional or question asking operation, a control structure that asks a true or false questions and then select the next instruction based on the answer. Okay, if this is true, then we will do this one, else that one. Okay, when we say iterative operation, it is loops. Okay, which means when we say loops, it's about what? Repeating. Okay, a control structure that repeats execution of a block of instructions. Okay, so how to represent algorithms? To represent algorithms, we can use the following. Okay, first we use natural language. On the second also we use formal programming language. On the third also we can use flowcharts. On the fourth also we can use pseudocode. When we say pseudocode, it is false code, okay? Pseudo means false. When we say use natural language, it is too verbose, too context sensitive, and relies on experience of reader. When we say use formal programming languages, it is too low level, requires us to deal with complicated syntax of programming language. When we say flowchart, it's a graphical tool that diagrammatically depicts the steps and structure of an algorithm or a program. When we say pseudocode, natural language constructs a modeled to look like a statement available in many programming language. Okay, first of all, let us start from flowchart. Flowchart is a diagram made up of boxes, diamonds, and other shapes connected by what? By arrows, not line. Okay, each shape represents a step in the process. Each shape represents what? A step in the process. Okay, and the arrow show the orders in which these steps are or process are occurring. Okay, when we say flowchart shows the operations and logical decision of a computer program. Once the flowchart is drawn, it becomes easy to write the program in any high-level language. In computing, there are dozens of different symbols used in flowchart. In computing, there are dozens of different symbols used in flowcharting. However, there are about 6 most common symbols. For example, you can see those symbols on slide 26 of chapter 1. Okay, if we see for those 6 are namely process. It has a rectangle symbol. The function of process is indicate any types of internal operation inside the process or memory. Okay, if we see process, it indicates any types of internal operation inside the processors or memory. This is the function of process. The function of input-output is used for any input, and the output operations indicate that the computer is to obtain data or output result. Okay, the third one is decision, used to ask questions that can be answered in binary format, yes or no, or true or what, false. This is the function of what? A decision. The fourth one is connector. Its symbol is like O or circle. The function of connector is allows the flowchart to be drawn without intersecting lines or without a reverse flow. Okay, the other one is terminal. The fifth one is terminal. The function of terminal is indicates the starting or ending of the program. When we start drawing a flowchart, we start by terminal. Okay, it indicates what? The starting or ending of the program or process, or interrupt the program. Okay, other are flow lines or arrows, show direction of a flow. Okay, it's so the function of flow lines are shows the direction of a flow. You can see on your handout slide number 26 if you want the symbols. Okay, note, for every program of flowchart should begin with the oval symbol containing inside a start or begin. Okay, and end with oval shape which have inside a stop or end. This is number 1. On second, we have what? In every program, flowchart crossing flow lines should be avoided. Okay. On the third one, only one flow line should come out of from input output and the process symbols. Okay. On the fourth one, only one flow line should enter a decision symbol, but 2 flow lines, one from each possible answer, should leave the decision symbols. These 2 are maybe true and false, or yes or no, or leave the decision symbol. Okay. The fifth one, all blocks of the flowchart are connected with arrows, not lines. Okay, it should have to be connected using what? Arrow, because arrow indicate the direction of the process. Okay. The last one, only one flow line is used in conjunction with terminal symbol. You have to know these 6 rules. Okay. Please read your handout properly and use this audio as a revision also. I hope you are preparing for your mid-exam. Good luck. Thank you.
Kabardahar University.